Now, what we've learned up until now, at the end of the day, all it did was create that function that our machine can use and predict any future input. And there's many applications of this, right? We now have a function that as a programmer or a developer, you can use throughout your code bases, maybe on a website, maybe on a robot, to try and receive inputs and predict something. Whether that image is an image of a snake, maybe a user sends an image that is not safe for work, well, maybe that predict model can predict and see if it should be uploaded or it shouldn't. But there's a problem here. You see, right now, we don't have that much data because we've only used a dataset that has 150 rows. But in real life, to train a really complicated model, you have millions and millions of rows. And this function of fitting and running the kn.fit takes a really long time. And most of the time, you're running these types of operations on something like a GPU or a graphical processing unit. And sometimes in the cloud, because you wouldn't be able to do it on a regular computer. Now, this part is very time consuming. So you wouldn't want every user that submits an image of a snake to actually run this function. We call this model persistence. And model persistence is important because next time we want to make a prediction, we want to save this model, this function, to a file and use that file for predictions. When you're on your iPhone and you're using, let's say, a machine learning feature, it's not going to run and train the model right there. Ideally, that model's already there on your phone. And this idea of model persistence is important. So let me show you how to do that. Once again, scikit-learn to the rescue. With scikit-learn, I can say from scikit-learn import job_lib. Now I can save my model using the job_lib module by simply doing job_lib.dump and dump the model somewhere. So we're going to dump the KNN, which is our model. So we're going to dump KNN, and we can call it whatever you want. Let's say mlbrain.joblib. That's the extension that we're going to have to use since we're using the job_lib module. And this stores the trained model in a file called a binary file. So if I run this, and I get an error. And that is because we have to do scikit-learn.externals. So this is just a way for us to import the job_lib module. So if I run this again, there we go. If I now go to my Jupyter notebook, you can see that I have a job_lib file. So now, in the future, instead of me retraining the model, I can just simply do job or model, since we assigned it to a variable, and say model equals job_lib. Actually, we don't even need the equal sign here. We can just dump this. So let's just run that. And we can just assign it now to the model whenever we need it. Say model equals job_lib.load and load the name of the job_lib that we want, which is the mlbrain. So now if I do model.predict on the, let's say, the X test data, and I click run, look at that. I get my predictions. And if I now copy the code, which was the sample data over here, so let's just cut that out and paste it in here. If I click run, there we go. Our model, and instead of predict, we'll just do model.predict. If I click run, look at that. This still works. So I was able to save my model so that I don't have to keep training it because that requires a lot of power so that my user, whenever a user wants to use my model, they just simply use the joblib load to load it up and then use the predict method. And this is how models work in real life. And anytime we make an improvement to the model, we simply just dump it again, maybe to a user's phone, so that they can use it. But this way, only the business owners that have a lot of compute power can train the models as they get more and more complex.